developers or aspiring developers? Nice. Anyone from DevOps? Okay. Any testing, QA? Okay. So this session would probably be useful to these folks. It's not that it will not be useful for the others, but you would find this more relatable. Okay. So with that, let's get started with designing an HA system. As I said, it's going to be a platform agnostic talk, which means there will not be any specific aspects about GCP or Azure or AWS or whatever. It can be implemented irrespective of what underlying platform is. Okay. So this is sort of like my promise for the next 30 minutes. We're going to be starting with the basic definition, then look at the different types of the HA system, how we can use a channel, which is sort of like the heart of the HA, how we can utilize that, a crossover or a failover mechanism, as it's popularly called in high availability high availability this thing. How you can monitor critical services, probing, preemption concept in terms of HA, and a floating ID, right? So, and then want to end the thing with certain sort of like a design pitfall. Okay, so quick intro about me. I've been in the industry for some time. Currently work as a software director for software engineering at Sonic. I actually lead the GDG Cloud Bantu chapter and also the Cloud Native chapter. I've got a special interest in serverless and containers. I also believe that multi-hybrid cloud is sort of like the future, and speak at multiple conferences, won multiple hackathons, etc. Okay, so with that, I'm going to set it on by defining what exactly HA means. This is a definition that I took from Wikipedia. All of you can read. I'm not going to read this out, but look at the ones which are underlined, right? It is basically a system characteristic, right? Just like scalability. Availability is also something, a system characteristic, but usually it refers to uptime. That is, your system should be readily available. So that's the system characteristics that we are looking at. And what does it eliminate? It eliminates a single point of failure, provides a reliable failover mechanism, and also helps to detect failures so that your system is more reliable or more usable in terms of its intended function. So this is what HA does. Simple thing. But why is there a necessity for HA? Because you can have your business application which could be very critical for your thing, and it has to be a centerpiece, a 24/7 availability. You cannot afford any downtime. And there is this increased concept of work from home, and your system and server should always be available. So there is more dependence for a highly available system. And also, it's irrespective whether you design a monolith or a microservice, a high availability or a perfectly working system should be readily available. So that is, HA can be implemented whether it is a monolith-based architecture or a microservice-based architecture. And also, it's like a very trendy topic. It usually comes up in the system design interviews, right? So you are in good hands for that particular question. So, okay. So this is something's gone wrong with the slide. The title is not coming up. But again, these are basically the types of HA system. On the first is basically the active passive, and the other one is the active. So there are two modes of HA. So as the name implies, if there are two nodes, and if it is in an active passive mode, one node is the one which is always accepting the request or serving everything. The other one also has everything, but it is sort of like ready to become active if something goes wrong with the first node. In the second one, both the nodes are serving the request, both are active, and there's usually some sort of like a load balancer which is in between to determine to where the request should go. And this is more of a case for a disaster recovery sort of a thing, that is the active act. So this is the context that I want to set when we design the HL. So with that, I want to quickly look at what the control channel means. Like I did talk about the control channel, which is a very critical piece. So here you have two systems, which is in a HA pair, and they have to communicate. So that's sort of like the messaging that has to happen between the two nodes, so that the system knows exactly on what parameters it has to affect or reliable a failover. So that's sort of like the control channel. So what's the importance of it? Because it sort of acts as the communication link. Because remember, your nodes are two separate nodes. There is databases in it. It's identical systems. So there isn't like a common database or a common system configuration that's between these two nodes. It's this channel that actually has this. So there is no central brain, so to speak, on what is the actual parameter for the whole system design. So it's entirely based on this channel communication that node 1 says hi to the node 2, node 2 replies back. So it is very important piece for the failover mechanism to happen. It performs the heartbeat mechanism, so that's what I was talking about. It is through the channel that they send and reply to the messages between them. And it's the control page. So over the channel, it can be anything. Okay, so when I say channel, it can be a TCP/IP network. It can be a UDP. It can be any means of establishing a system. You could do this with, how many of you are familiar with Golang? Okay, so there are channels in Go, right? So you could use that to implement this. So it's language independent. So I'm just took Golang as an example because there are obviously channels, and this is channels, so it's very easy to read. But everyone who's not from Go, it's sort of like a wire of communication. You think of it as like a Ethernet cable, right? So you could establish a link, like the last point can be TCP/IP stack. Now, this is, as I mentioned, my talk is platform agnostic. So I also want the code to be also language independent. So what this does is, it's basically an enum or an enumerated type of what the actual things can be conducted between the channel. So if you look at it, the heartbeat is the first one. So obviously through the channel, we can send the heartbeats between node 1 and node 2, right? You can have some sort of like a configuration settings, not priority, right? I'll come back to that later. The DB sync status. So assume you have a database. It could be any database, relational, non-relational, CSV files, graph databases, right? So whatever data that you want to communicate, so that can be your third parameter, right? Software version. You need the two nodes to be running identical software versions. Only then you should effectively run a failover, right? So a force failover, do you want to increase the priority? What is the prop IP that it's going to be there? So I'll come back to what is the prop IP detail later. What is the uptime? Each node, so node 1 wants to know the uptime of node 2. Node 2 wants to know the uptime of node 1, right? So the uptime gets carried over, and you can also have some sort of like a licensing data that is to be set. So think of this as the data points that actually gets carried over between the HA channel. Nothing else. This is an enumerated type, and I've intentionally done it because I don't want to confuse it with the code. The other way, I did talk about the channels. If you want to do it in a different language, like other than Go, like you want to do it in a more modern language, like Go is a modern language, a more easier language like a Python or Rust, whatever, right? You could even have some sort of like an off-the-shelf thing called as a publisher subscriber. All of you must have heard of the publisher subscriber, right? So there are certain events. I did talk about this. All of these could be topics that could be embedded in your publisher subscriber. So there are two nodes. the two systems. So when I say nodes, I am talking about the HA nodes, but actually it can be two systems. System 1 can be a publisher for system 2. System 2 can be a publisher for system 1. So there is a publisher and a subscriber that is running in both the systems, and both of them have to subscribe to it so that the effective channel gets completed. So this is an alternative way of establishing a channel, right? So this is very off-the-shelf way to do it. Because if you don't want to implement your custom logic, you can go for a pub/sub model. You can have those topics created and then have it subscribed between the two nodes, right? And there may establish language specific libraries. So some of them are basically RabbitMQ. There's also the Centrifugo library which is there, and Google pub/sub. So these are third-party applications that you could readily use it, have it installed on your two applications which are there on two nodes or two containers or whatever, right? And then have it done instead of going with the programmatic way. A very simple way. So now let's dive deep into what actually means in the heartbeat mechanism. I didn't tell in the previous slide why or what is the advantage or how do we determine a crossover. Because through the channel, one of the functions that gets established is the heartbeat. Now, how do we implement the heartbeat mechanism? Or what is it? It determines the overall state of HA cluster. So cluster is basically a two nodes or two systems which are in HA. And you need the system to be there as the heartbeat mechanisms to be set. So the heartbeat is very important because it overall conveys the overall state of the HA, right? And you want your system to be failing over for certain scenarios, right? It could be like a network loss. A node 1, which is in the active mode, is doing some very important computation which needs network access. Suddenly, network goes away. So it has to fail over to the second one. So that is where the second node becomes the active node, and that is where the HA comes to play. So in the heartbeat mechanisms, it can be monitoring a network loss. It can be monitoring a power outage. For example, power goes for node 1, so it has to fail over. The node 2 becomes the active node. System crash, host corruptions, right? These are all scenarios that you could handle. And certain threshold mechanisms of failure buffer. So what it does is, this is important because you do not want a failover to happen immediately. For example, there are two systems which are in HA pair. There is a momentary loss of network. Should you fail over immediately? Well, it depends on your configuration. How much time can I afford a loss of network before I reliably switch over? Maybe I'm pinging to some server, right? There is a central server that basically shows me I'm doing a continuous ping 8888. That's the Google IP, right? So if suddenly the ping becomes silent for continuously for about 5 pings in a gap of every 6 seconds, right? So after the 30th second, I can now say that node 1 has completely lost the network and I need to do the failover. So these are thresholds that I can configure. Or I can say that there is a CPU spike in the first one and it's not coming down and I'm keeping monitoring it for the last 15 minutes. So I now need to perform a failover. So this is sort of like the various threshold checks that you can actually do. So this is a sample JSON. Again, nothing fancy, no fancy code, right? This is something that JSON can be consumed by any programmer. So here I've put a heartbeat interval as 10. So and a failure trigger level of 6. So every 10 seconds, the unit of time, I'm taking seconds. So every 10 seconds, I'm setting a heartbeat to make sure that the second node is active. And if I don't feel that the node is there, after the 6th attempt, I'm going to perform a failover. So that is what it means. So 1 minute, I'm going to look at the threshold for 1 minute to see if the node 1 or node 2, if either of them is not available, I have to now perform a failover because the system has become unstable or the overall HA cluster is at risk. So this is a sample crossover mechanism that we can implement. Now, there is another way that you can effectively perform a failover. Assume you have a system in which networking is not very critical, right? You need certain processes to be monitored. You have certain critical processes to be monitored, which if it fails, you have to now perform failover. So you could effectively perform a crossover mechanism even for certain processes which are not there. So you have maintained a roster of important processes. So you identify certain process. You have a threshold mechanisms for self-recovery. That is, if a process gets killed, you would have some sort of like a watchdog, which is there, which should effectively kickstart the process. Like if that also doesn't work, then you have to perform failure. So that is what over here. So you can have like 1, 2, 3, 4, 5. These are my critical processes that I need to monitor, which should be there in my HA cluster in both my nodes, node 1 and node 2. If any of them fails fails to be running, even after my watchdog has tried to kickstart it, after a reasonable amount of time, I should now perform a failover. So this is the other thing that we can effectively monitor. So here again, going back to JSON, nothing fancy. So I have a JSON array of service status, which has the name, service 1, service 2, whatever, it could be any service, any process. It shows the status, and then a type, and then a weight. So if my process is a critical process, and if it is dead for a certain amount of time, you can see that service number 5 is a critical process and it's been stopped. And what would now happen is there is a watchdog mechanism, right? Watchdog would be a simple shell script which could basically check for if the process is there in a Linux system, right? And if that process is not, it will just try to kickstart it. But if the watchdog has now failed to start that process after so much time, the node will basically send an alert to my passive node saying that the system is not able to start this critical process, and now it has to effectively start a kickstart mechanism for failover. So this is a sample service monitoring. So the other important aspect in terms of HA, so we looked at the networking or the hardware. We looked at the way in which we could use a probing, I believe it's just now coming. We looked at the service monitoring mechanisms, and now the third way in which you could implement HA in terms of networking is basically the probing. So what it does is, you have your application which is there, which needs to basically check for a certain server to be available. You have an internal server which does certain business logic, and your software needs to talk to that server for certain amount of business logic. If that server is not available, you need to now perform a failover because it's not able to probe it. The other system may have the network issue. System 1 could possibly be having some sort of like a network. So this is a continuous probe to a specified host name or IP. It can be at specified intervals, again just like the heartbeat, and also it again checks for the failure buffers and all the other thresholds to avoid. Okay, so what it does is a probing functionality could be an external IP also, or it could be an internal host. So this is a case from our company where we have customers who are US federal customers. They have very strict mechanisms that there is no network which is outside there, right? They have no internet, like the US Fed customers, right? The US government. So what they'll do is, if we implement HA, we would probably check if we are able to reach the internet. But they have no internet, it's all their intranet, like Pentagon, White House, etc., right? So they have their own critical DNS servers or whatever which is inside or hosted by the US government space. They would probably check for that particular server. So now if that server is not reachable, then we would have to effectively implement a failover. It's not just the external network, right? So there are probing internally and also externally. So that's an additional overhead that you could check. And there could also be availability for a third party. Say for example, I am using a Python application And that Python application is very critical for which I'm implementing HA. Now, say for certain Python applications, you need some sort of like a package manager, right? So Python, Go, etc. So you could even check if that application has access to those package manager roles. So it could be a probing for anything. It's not just a hosting or IP. It could be for anything. So this again is a sample mechanism. You have a prop interval for 20 seconds. So every 20 seconds, I send a prop to any of it. And if there's a prop failure continuously for 3 times, then I have to inform or take the HA mechanism to perform a failover. So here it probably gives a result as true, 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 which means my last 3 props have been success. So the HA will continue to function the way it is. Now, as I mentioned in the summary, the topics that we're going to be covering, I'm going to segue into what exactly is a floating IP. So floating IP is basically a mechanism in which you could effectively hit the active node. Say you have a HA cluster which has been set up, which I'm taking for simplicity 2 nodes, an active and a passive, but it could be n number of nodes. Theoretically, a system admin would not know the hosting or IP for each of it. End customer would probably hit google.com, but is google.com a single server? No. There are multiple servers which are there which is working in HA, and that is a DNS that is being translated to a single IP address. That IP address will not be a single system. It will be something called as a floating IP. So what is a floating IP? Floating IP is a concept which effectively determines what is the active node. It will always tell you it is at the layer 2. So if you are familiar with the OSI model, layer 1 to layer 2, the MAC address, it ties up with the MAC address. So the floating IP will effectively tie up with the MAC address of that particular system, whichever is active. And whenever you type that host name or IP, it will always prompt you or give you the response from the active IP. So this is a very important concept in terms of HA, because it determines the active node, and it is usually configured in the same subnet space. Because if you are looking at the IP before network, say 10, 5, 6, 7, right? A single IP address. I cannot have something like a 10, 1, whatever, 10, 1, 2, 3, because these are 2 different subnets. But effectively, you can keep a networking between them, but usually it should be in the same subnet space. So here is a good example of what it is. You have 2 nodes which are HA nodes, which is there in the HA cluster. The node 1 is having a priority of 200, and the node 2 is basically having a priority of 100. So you give, or your HA logic determines it to be the active node, which is the 200. And then the floating IP, I did tell about the floating IP. The floating IP will obviously relay the parameter only for, or when you hit the floating IP, it will give you what access to the node 1. And this is how you basically determine it. So as I said, it works in the layer 2 space. The IP is bound to the MAC address, and it will basically serve the thing. You can use certain packages like keepLID, HA proxy, which basically does this task for you. So now we effectively move on to preemption. I have just like about 5 minutes of my time. I think I'm doing okay. So essentially means that the primary takes back the active node. Probably we could basically create it with an example. So here, this is how my HA cluster looks like. Primary, which is active, you can see that it is green, and the secondary is a standby. So this is the initial HA status. Now, for some reason, the primary has become down. So now your HA logic will kick in, and effectively the crossover has happened, and the secondary is now the active node, right? Some failover has happened, depending on whatever concepts we discussed earlier. It could be a network failure, it could be a service failure, it could be a prop failure, it could be any of the other packages that is not reachable. So now your secondary is now active. Now, if preemption is enabled, so this is the concept in HA. If you are enabled preemption, what would happen is Assume after some time the primary is back up, right? It has recovered from that error state and the primary has back up. So what should happen in a normal HA scenario? Assume there is no preemption. So now the primary is come up and now the secondary is active. What should happen now? In a normal scenario? Okay. So what you said is the preemption scenario. Okay. So in a normal scenario, what would happen is the secondary now continues to be the active. It doesn't do anything. It just every request will now be served from the secondary, which is that, and the primary, as it was in a faulty state earlier, it has now come up. So let it be a standby. So now, but if you have enabled preemption, or if you have configured preemption, the original status quo is now come back. That is, originally the primary was active, it's recovered, so let it be the active node, and the secondary continues to be in the standby. So this is the preemption thing. Usually preemption is not configured, because assume you have a system where you have a graph database or relational databases or everything, so these are running in both the things, and if it crosses over immediately, as soon as the primary comes back up, there could be errors in the database and there could be a problem unless you configure it or you configure error handling in a much more robust manner. So usually preemption is not enabled, but there are use cases where you have to have preemption enabled, right? So with that, and we are the fag of this talk. So you're going to look at the design gotchas and the pitfalls. So you should never store the data about the config in a DB, right? What happens is there is this logic that I've talked about. I did show about a bunch of JSON examples, right? Where would you store those JSON examples? I mean, those JSON configs or whatever, JSON, XML, anything, right? That has to be stored somewhere, yes. Yes, it has to be separate. So it should never be part of your HA system. Because if you store the HA config within the system itself, what happens when the system fails? So that should be independent. So that should be completely separate out and it should be configured. Otherwise, if it's not shared, there's something called as a HA split brain. That is, my first half of the system knows something, the other half doesn't know something. So this can lead to an untoward behavior. So this is something called as a split brain. So your HA configuration or whatever stuff that you do for the logic of HA should be residing independently or in a common shared location, accessible to both the nodes to prevent the split brain condition. And the third one, there's a huge design difference. Whatever example that I've talked right now was mostly the active passive. The second one is the active implementation, and there is like a completely different, because both the nodes are available, both the nodes are ready to serve the request. So there should be some sort of like a different design. So whatever design that you do for active passive should be entirely different from what you do for an active scenario. So I guess that's it. I mean, this is the takeaway. Choose the right architecture depending on your availability. You should decide whether you want an active standby or an active. You should have a robust channel. I cannot stress this enough. Either you could do it the customized way, the way you want, by using certain programming languages, or you could use third-party libraries like observe mechanisms to do this, right? You need to have a failover and a heartbeat mechanism so that it is proper, and that's the reason why I asked if there are any QA or testing people over here, because proper testing is paramount to implementing HA. And there should be a reliable third-party package, which can basically, so we use something called as the Keep Alive, which is a third-party application. We could also use something called as a HA proxy for implementation. So yeah, thanks again. I believe I have some 1 minute probably for questions, but we can take questions.
Oh wow, great. Please, sir, I'll come with the mic.
Hello everyone. So first of all, Mr. Oommen, thanks a lot for this wonderful session. And I seek apology if I mispronounce your name.
It's Oommen, yeah.
Yeah. So my question goes like this. So whenever we talk about HA, so it is in regards to whether it is cyber security or it is kind of networking. So it is kind of plethora. So I just want to ask you that how HA can ensure for the Indian banking system whenever all the things, all the industries are dependent on Indian banking, and how we can have such a thing, because still we have the IBCC which is in the picture, but still the process is a bit cumbersome. I would like to.
I didn't catch it.
IBCC. So IBCC is a kind of platform or an entity that is designed especially for the Indian banking, but still the process is cumbersome. So why there is a downtime and there are a lot of compliances that are happening?
Yes. So it's a good question. I am actually relatable to it because my first job was at Infosys, which makes the Finacle, the banking core banking solution, right? And at that point of time, there was no cloud, right? So probably that gives the indication to how old I am. But right. But anyway, yeah. So coming back to now your question, how we can implement HA for a banking solution. The talk or the design paradigms that are basically used over here are independent of whatever application or whatever solution. So if you look at it, neither did I talk about GCP or AWS or Azure, neither did I talk about any languages or anything, right? So these are certain system design ideas that you could implement on any application. So it could be banking, healthcare, travel, tourism, doesn't matter. It depends on your application logic. It could be microservice, it could be a monolith, it could be containers, it could be Kubernetes or whatever, right? It could containers or serverless, right? I mean, serverless, there is no need for HA because it's contained by the cloud application. So these are high-level pointers that could be taken by the software development team to implement HA. So it doesn't matter, honestly.
Okay, that's the talk. So if I have a scenario use case where, let's say I want to send a cross section of the traffic to one node and the rest of the traffic to another node, where both nodes are running different versions of the code, then do we use active or?
Yeah. So that's your scenario is more towards leaning to active with active passive internally. So this is more like a disaster recovery scenario where you have one node, say in Bangalore, one node in Delhi. Both are active, and within that active node of Bangalore, there's an active standby. There's an active standby in Delhi. So you can have a certain load balancer which will basically decide the load on how my data should be going to the Bangalore or to the Delhi.
So my question is like you have explained like when exactly like what preemption HA is, but could you please give some scenario where we have to do this?
Yes. So let's take an example of my product, that is a firewall, right? I come from a security background. Sonicol designs firewalls, and where would implement preemption, right? So you have two firewalls, right? One firewall, say it's been under attack, right? There's been a DDoS attack, or there's been some actor who's just taken it down. But the IT team has figured it out, and it has made sure that the network is now proper, and it now wants that to be the primary concern. So when the firewall was down, the second firewall took over, the secondary was active, right? But now the IT team has more confidence in the first firewall because that is where the central traffic and everything is coming. So you want the preemption to be now enabled. So if the preemption is enabled and if the firewall has come back, it will automatically switch over to the other.